Okay. All right, so we're going to start the lesson today and go back and pick up the trig. And I just told the rest of the class for the recording that I didn't recognize the problems on the Chapter 7 test as being trig problems, because what's supposed to happen is that the degree of the angle is supposed to be in the corner. Right? And because of the way that it was typed out, that degree was down here, and I didn't see that it was degrees. I thought that was the length. Right? And so therefore, I was not giving you enough information on what you're supposed to know for trig. Okay, so the first thing we have to do is we have to talk about the three basic trig functions. And they are sine, cosine, and tangent. So write those in your notes. Sine, cosine, and tangent. All right, now, trig values are nothing but fractions. They're nothing but fractions. But the values of the fraction depend on the size of the angle and the numbers that are given. But if you'll notice, in proportional situations, the fraction will always cancel out. Like, for instance, if the top number was multiplied by 2, the bottom number was multiplied by 2, those will cancel when you simplify the fraction. Right? And so all similar figures for the same number of degrees, the fraction number is going to boil down to the same value. That's why they can be hardwired to the calculator. Okay, so what we have to do is define what sine is. And the calculator uses just the first three letters. So this is sine with a long I, even though it's S-I-N in the calculator. All right, now, it is defined as the opposite leg over the hypotenuse. That is sine. The opposite leg over the hypotenuse. And what I teach is, for the given degrees, you put an arrow through the inside of the triangle. It's pointing to the sine leg. Right? And so for 20 degrees here, where is the sine leg located? All you do is put the arrow, and that becomes the sine leg. So is this problem asking you for the sine leg? There's nothing there, right? So this problem's not asking you for the sine, so it must be asking you about the cosine leg, which is the other part that makes up the 90-degree angle. Right? So this is the sine leg, and this is the cosine leg, and to make the fraction is going to be cosine over the hypotenuse. Sine over the hypotenuse. Right? Tangent is the sine leg over the cosine leg. All right? So, as far as definitions are concerned, if they ask you for the sine leg, it is the leg that's opposite, so it's this leg over the hypotenuse as a fraction. Whatever that number is, that's the value for the sine. All right, now get your calculator out. And in your calculator, put sine of 58 degrees. So put sine 58. All right, now. All right, what'd you get, Bennett?
0.9928.
All right, what'd you get?
0.8480.
Okay, now, they did the same thing, they just got different numbers, okay? What you have to do is you have to check and make sure that you are using degrees and not radians. All right? I did an entire math test with radians instead of degrees. And so every time I got an answer, I knew it was wrong, but I forgot why it was wrong, and so I ended up passing the test, but it was a problem. So what you're going to have to do is you're going to have to go to mode, which is up at the top, and under mode, if you look down the second or third line it says radian, and if radian is black, get on it, slide over one, and press enter. So degrees. Okay, now were you on radians? Okay, now there are problems where you want the distance around the circle, and that is in radians. Right? But for this purpose, for the elementary trig, we're going to use degrees. All right, so so now if you go back and look at it now, you'll both have the same number. Okay? All right, so here's what this said. It said that the sine of 58 degrees was equal to what? What did you say? 0.848. What?
0.848.
0.848. Okay? Now, that is this side over the hypotenuse. So that means that x over 32.3 is equal to the sine of 58 degrees. So how do I get x?
Multiply by 32.
So you take this times 32, and you have the number that this has to be, so that this over this is 0.84. Okay. Now, if we wanted y, we don't use the sine leg, we use the cosine leg. So we want cosine of 58 degrees is equal to y over 32.3. So how do I get y by itself? I put in the calculator 32.3 times cosine 58. And that will give me my value of y. Okay? Now, not hard, but because we didn't talk about it, I didn't think it was fair for you to have to get that from the instruction. Okay? All right, so does that make sense? So if you have a given angle, you can find the values by setting up the correct fraction and having it equal to whatever this is. So what are you going to use here? We're going to use 20 degrees, right? So if I want sine of 20 degrees, it's going to be v over w. That's two variables. I can't use that, right? But I could say that the cosine of 20 degrees is equal to 17 over w. Right? And if I think of this as a fraction, I can cross multiply and then divide. So these two change places, and w is equal to 17 divided by the cosine of 20 degrees. Okay, now let's put that in the calculator. Now the newer calculators really help. So you do 17 divided by cosine, and it already gives you the grouping signal, or the grouping signal, 20, all right? Cosine of 20 degrees. All right, when you press enter, you get 18.09. Okay, that means that this is 18.09. Okay? Now, the tangent function is sine leg over cosine leg. Okay? Now, I'm going to show you what inverse does. All right? I'm going to use the tangent function, but instead of tangent, I want second tangent. So press second tan, and you notice you have tan -1. That stands for the opposite. So we're going to put the fraction in. It's going to tell us the degrees. So the tangent is the sine leg over the cosine leg. So inside the parentheses, you're going to put 18.09.
How did you guys get 18.09?
That's how we solve this.
Yes.
17 divided by the cosine of 20. Did you do that one?
I did cosine 20.
Oh no. If you look mathematically, I've got to cross multiply. The w will come up here, then I have to divide by it, so I end up with 17 divided by cosine 20. Put that in the calculator real quick. 17 divided by cosine 20. 18.09? Okay.
Wait, what if you...
All right, that's the mathematics of it. That's the algebra. Now, so therefore, I wrote that down here because that's what we got for this. All right, that was, oh, I'm sorry, wait a minute. That was a W, that was here. Thank you. All right, is that what you were saying? Yeah, it should have been here.
I'm confused. What if you multiply the 17 on both sides?
If you multiply the 17 both sides, then you have 1 over W. We don't want that. See, what I've got here is I've got a fraction, so I'm going to cross multiply. The W is going to come up here, but then I want the W by itself, so I end up dividing. So it becomes 17 divided by. Okay, and because I put it in the wrong place, we have another problem. Because I was going to show that that was 20. So, all right, let's do this. And I know what we can do. The third part, if this is 1809, how do I find that part right there? How do I find x? Isn't it this squared minus this squared is x squared? Agreed? That's Pythagorean theorem, that's part of this. So start with second square root. Get your square root up there. Can't see it. Second square root. And then we're going to put 18.09 squared, 18.09 squared minus 17 squared. And it's all under the square root. That makes this side 6.185. Did I get that? Okay. Yes, we need a calculator? You got one? Huh? Oh, you do. Okay, all right. All right, now. Okay, well, I want to show you what happens if we don't know. If we don't know. All right, so if I look at this angle right here, that's the sine leg, right? So we're going to use second sine, and in that, instead of the degrees, we're going to put the values because it's the inverse. So it's going to be 6.185 divided by the hypotenuse, which is 18.09. And when you close parentheses and you press enter, you get, within the margin of error, 20 degrees. Okay, now, what would the cosine be? The cosine would be 17 over the hypotenuse. So do second cosine. Second cosine of 17 divided by 1909. I'm sorry, 18. 18.09. And when you press enter, you get a little bit different number because we rounded it differently, right? But within the margin of error, they're both 20 degrees. So if you don't have the degrees and you have to find it, you use second sine or second cosine or second tangent for two numbers that you know. Okay, now let's look at this one. That's what this problem says. All right, I need this angle. These two sides are both right angle legs, so therefore I have to use tangent. Which number goes on top?
Oh, it's the opposite angle. So it's
Sine leg. Sine leg on top, right? Therefore, sine leg, so I want second tangent, which is tangent -1 of 30 36 over 62, and it's going to give me, that will equal X number of degrees, which is that angle. All right, that is one of your test problems. So let's try it. Now, why am I using tangent? Is because I had both legs. If I had a hypotenuse in one of the legs, I would use either sine or cosine for the numbers that I have, and we'll get to that in a second. So this one has to be second tangent of 36 over 62. Okay, and you have that it is roughly 30.14 degrees. Right, see that?
So would we round that to 30?
No.
Or just...
30.14.
We could guess that it would probably be 30, but for the equation's sake, we want to keep it.
That you're gonna have to get down.
Oh, no, it's to a decimal. That might.
Okay. All right. Now, if I know that this is 30.14, then this has to be 90 minus whatever that is. Right? So we could actually calculate this third member angle by the fact that the three of them add up to 180. So I take 180 minus 90 minus this, and I can get that third angle without having to use the trig. I can use the Angle Sum Theorem for that. Okay? Now, this problem, I can't use tangent because I don't have two numbers. For this angle, that side is which function? Starts with an S. It's the sine function. It's the sine function, right? So I can't use the sine because I don't have a number, so what am I going to use? Cosine. And so I want second cosine so that I have cosine -1 of 56, that leg divided by the hypotenuse. All right, so second cosine of 56 divided by 73, and that gives me 39.90. So 39.90 degrees. Okay, now what would you use here? For part C. Okay, this is how I check it. In order to use the sine, I've got to have a number opposite the arrow. I do. Now, that's the hypotenuse, so I can use sine. If it was this and this, those are the two legs, so I'd have to use tangent. And second tangent will get me the value, right? When I have a problem like this, all right, now, what two sides were I given here? I was given the sine leg over the hypotenuse, so in this case, I would say the sine of 47, which is a number, equals x over 29, multiply both sides by 29. 29 times the sine of 47 will be the length of that side. And I know one thing, it's less than 29. How do I know that? Because the hypotenuse is the longest side of the triangle. Okay, does that help? Now, with that information, if you go back and study that and redo the problems, if you haven't done it, the problems on this supplement, then you should be able to then do your the 4 problems that are trig problems in chapter 7 test. Okay, and again, I apologize for not recognizing that they were there when I told you what the reason was. So, okay, all right, now, all right, let me see if we can move to the new stuff. All right, this I can kill. Whoa, where'd it go? Oh, man. save. That's weird. All right, give me a second here. I've got to, it didn't save it here for some reason. All right. All right, we're supposed to be doing chapter 8 this week. So chapter 8 was similar figures. And then we're going to be looking at chapter 9, which is perimeter area and volume of similar figures. Okay? All right, now, so let's look at, you were supposed to bring in your work for chapter 8, and I hope that you have it. For some reason mine didn't copy, so I'm trying to get this together for a second here. All right, so we need, all right, page 336. Okay, we've already done part of that. I need textbook. Praise the Lord, there it is. Okay, 336. All right, now, this is the materials that we were going over last week. Okay, so it says for problem number 10, this is on page 336 of the skill review. All right, now, problem number 10, you're supposed to find the x and the y. All right, now, in the outside triangle, you notice that the right angle is in the top corner. All right, so therefore, what kind of triangle do you have there? Do you notice you have a 3 and a 5? Does that ring a bell for right triangles? What is it? 3, 4, 5. So that means that the y is 4. Okay? And it is also, it is the long leg of the triangle. The 3 is the short leg of the triangle, and the 5 is the hypotenuse. Okay? Now, we have to take that idea and we have to get a value of x. And one of the things that we worked on last week is that these 3 triangles are all proportional. Okay? They're all proportional. So what I'm going to do with this particular triangle, I see the little one. In the little triangle, the hypotenuse is 3, and the long leg is x. Right? in the big triangle, the hypotenuse is 5 and the long leg is 4. So what's the value of x? Use your cross multiply.
It's 12 over 5.
12 over 5, whatever that is, okay? Now, had I not chose that one, if I would have chose this triangle, I would have had that this is the short leg. And so x is the short leg, and the hypotenuse is 4. And in the big triangle, you have 3 for the short, and the hypotenuse is 4. When you do the cross multiplying, what's the value of x? 3 times 4, 12 over 5, right? So it didn't matter which one you use, provided that you keep straight what each part is. That's why I like to use long leg and short leg. Okay? And then as long as you have the proportions set up correctly, those things will always work out quite nicely. Question?
Sorry.
All right.
I was just saying that I thought it was opposite and adjacent. Does it matter?
All right, now, opposite and adjacent are for trig functions, not for these similar triangles. Because what happens is that if you look at the angle, right, if I'm up here for the big triangle, right, if I look at it, this is the right side of the big triangle, and this is the left side of the big triangle. That's another way to do that. If I go to here, right, this is the left side of the small triangle, and this is the right side of the small triangle based on where the legs are. If I use this third one, this is the right side, and this is the left side of the second. So I've got the large one where these two are left and right. I should have done this in different colors. I've got the small one where these two are left and right, and I have the middle one where those two are left and right. All right, and those are the corresponding parts of those similar triangles. Okay, now, if that's what you're meaning, then that could be right if you're talking about adjacent. But see, when I think of adjacent, I'm thinking of this angle down here. The adjacent side is here, and the opposite side over here. That's a trig issue. That's not these proportions issue. Corresponding parts are either left side, right side, or short leg, long leg.
Yes.
Hypotenuse, okay? All right, so if you have this figure, again, whoa. If you have this figure, again, we have proportional sides. All right? So the 5 is the short side, or the short leg of the big triangle, which is 5, and the long leg of the big triangle is 12. Now, if I'm going to use the x, I have to use a leg. So I'm going to use, I can't use one here. I'm running out of problems, so what I'm going to have to do is to calculate the other side. All right? And in this case, if this is 5, 12, I happen to know that one. That makes this, the big hypotenuse, 13. Because this is the hypotenuse of the smallest triangle, isn't it? So this one doesn't work because I don't have the values. So now I say that the hypotenuse of the big one is 13, and the long leg is 12. The long leg is 12. And then that makes, in this triangle, the hypotenuse is 5, and the long leg is x. And so these two are going to trade places. It's going to be 12 times 5 divided by 13 is the value of x. All right. but if you work at them that way, now, if you didn't know this was 5, 12, 13, and you're going to go square root of 12 squared minus 5 squared, or 12 squared plus 5 squared. We'll give you that. But I happen to know, just like the 3, 4, 5, I know 5, 12, 13 is also whole numbers. Okay? All right, does that make sense? Okay, so those are the figures that we have to work with. And again, all of these in A through D are all working with those proportionals. Okay, now when you get to F, the proportion that you have is 3 and 8, which is the small triangle and the big triangle, and its equivalent is x and x plus 6. So you're going to have a quadratic. All right, look at H. H is easy to look at. Okay, now here I'm going to look at the triangle angle from the top. The x on the first triangle that you see, the x is on the right side. In the other triangle, the 2 is on the, I'm sorry, in the first triangle, the x is on the left side. In the second triangle, the 2 is on the right side. All right, so are you going to have proportions with that? Not that way, are you? Okay. They are similar if the proportional distances between those are set up, because the vertical angles, right? We have like angle, side, angle. All right, and so if they're proportional, then there has to be a relationship between 3 and 4 and a relationship between 2 and x. All right, that one's not as easy to look at as this one. Okay, now what do you see here? You see 10 and 10 on the isosceles, right? Then if the angles are the same, what has to be on the other side? It has to also be isosceles, right? So what's the total length of the top of the triangle? It's 14, right? What's the total length of the bottom if it's isosceles? It's 14. So then what does the y have to be? It has to be 4, right? Now, so you have two things. The proportion of the 8 and the x is the same as the proportion between 10 and 14. Right? So you'd have 10 over 14 is equal to 8 over x. Setting that up. But the y, 4, has to be the same because the lines are isosceles triangles. All right, now in J you have 2b and b. So what is the proportions? All right, that the smaller triangle is half of what the larger triangle is, or the larger triangle is 2 times what the smaller triangle. What does that do to the angles? Does it change the angles? So is the small one 35 degrees for x? If triangles are similar, what do you know about their angles? Say it loud. They're the same, right? So therefore, these triangles are similar because one is twice as big as the other, or half, depending on which one you're looking at. So if they are similar, then the angle 70 is the same as angle x. So x has to be 70 degrees. because the angles don't change. The sides change. That's why in I, that's why we had to set up a proportion of 10 is to 8 as 14 is to x. But the angles don't change. Okay, so what about L in this bottom corner? All right, you notice that the angles are set up the same? Okay, so what's the proportion? They're the same way, so 3 is to 5 as x is to 3. Okay. All right, now, if you double the lengths of the side, what happens to the length of the hypotenuse? If you double the lengths of the sides of a right triangle, what happens to the hypotenuse? Okay, all right, let me ask you this. The length of the hypotenuse is a squared plus b squared. What is 2a squared? What's 2a squared? 4a, right? And so it becomes 4 times as large. Right now, the problem with using double is that it doesn't help you when you get to area. So let's use 3 times. It's tripled. Okay? If you go from A to 3a, what happens when you square it? What's 3a squared? 9. So this becomes 9a squared plus 9b squared, and that's going to equal how many c squareds? It's going to equal 9c squared. Right? So if we doubled it, it would be 4a plus 4b would have to be 4c squared, right? Because both numbers are multiplied by 2, both sides. Now, what happens if you have volume? What happens if you have volume? How do you find volume? It's length times width times height, right? So if the first one is tripled, I'd have 3a, and the second one is tripled, and the third one is tripled. Then what happens to the volume, which is a times b times c? It's going to be 27. So if you triple the length, you have 27 times the volume. If you triple the length, you have 9 times the area, because it's only 3 times 3. But in volume, you have 3 times 3 times 3, so it's 27 times bigger. Okay, self-test. All right. Why are they similar? This is isosceles, right? So this is 80. That's 160. That makes this 20. If this is 20, then that makes this 160 divided by 2, which makes that 80 and 80. And so they're similar because they have the corresponding angles are equal. Right? What about here? What 55 plus 35 equals 90, right? So that makes this 55, so that the 3 of them add up to 180. It makes this 35, so the 3 of them add up to 180. And so that they are similar because their corresponding angles are similar. All right, that's the part of that particular test that I wanted you to see. Okay, so chapter 8 is going to be those types of figures, and you work on that. Okay, now I need to get to 9 because that didn't show up either. Okay, how do I get there? Let's go go back. Okay. Back. It's cumulative. Okay, here's this normal right here. Okay. All right. All right. Suppose that P and Q are similar figures, and the ratio of similarity of P to Q is 3 to 2. Okay. Now, which one is larger? Which one is larger if this is the ratio? The Q is 3 and the P is 2. Okay? The Q is larger, right? Because the Q is 3 and the P is 2. All right. Now, how much larger? When you simplify, this is 1.5. So this is half again bigger than P. Okay. Now, if P has a perimeter of 6, then what is the perimeter of Q? All right, now, the perimeters are in the same relationship. All right? And so P to Q is 2 to 3. Right? Because they're upside down, right? So if the perimeter of P is 6, then X is the perimeter of Q. And what happens when I do the cross multiplying? I have 18 divided by 2, which makes X 9. Now, if P has an area of 2, right? That means that I have 2/3 for one times 2/3 for the other. So the area will be 9/3. I'm sorry, 4/9. The area will be 4/9. So if 4/9 is the area relationship and P is the smaller, it is 2 to X. And so we'll end up with 18 divided by 4. Right now. So whenever you're doing area, the distance, the multiplier difference, there's 2 of them because it's one number times another number, so these end up being double or squared. Okay? Now the edge of a box is tripled in length. What happens to the volume? All right, that's the one we just did. What happens? So if you triple the area, then you have 3 times 3 times 3, and so it's volume times what? 27. Okay? The surface area is going to be length times width. And so if you triple it, you're going to have what for the surface area? What do you see? It's no longer L times W, it's
3 times that.
so what, how many, so that it's area times what?
9.
9. And if it was perimeter, it would just be 3 times as large, because it would be 3L plus 3L plus 3W plus 3w, and it would just be 3 times what turns out to be the perimeter. Okay, so those are the, and all of those are parts. And, okay, now, do you notice this is this? So the big one is 2 times the little one. See that? So the small one is what relationship to the big one?
Half.
It's half. If the other one's 2 times as big, then that one has to be half. Okay, so it depends on, and because this says CDE, that's the small triangle. And CAB is the big triangle. So if this is twice the size of the small one, then the other one is 1/2 of the big one. Now, this particular chapter was a lot simpler, I think. All right, the picture shows a regular tetrahedron. That is, it's a triangle pyramid, each of whose 4 faces are equilateral triangles. All right, if each edge is a length of 6 centimeters, find the surface area. Okay, so that's the surface area. So the area coming down to here, if this is a right triangle, if this is 60 degrees here, then this is the bisector of the side and the bisector of the angle. So now I have a 30, 60, 90 right triangle. Okay? And this side is 30. If the 30 side is half of this, because it's a bisector. So if this is 30, then this whole length is 6. And this is 3 times the square root of what number underneath the square root? If it's a 30, 60, 90. This goes back 3 chapters. All right, you and I talked about it on Friday.
What is it?
All right, I have the altitude coming down on this face is a bisector of the side, which makes that side 3. And it bisects this 60-degree angle, so that side's 30. In a 30, 60, 90 right triangle, the small side is half of the hypotenuse. So if this is 3, then that started out as 6. But what is the square root number that goes under there?
3.
3. That's good. That's what I wanted to say. So that makes this 3 times the square root of 3. So the area is 1/2 6 times 3 square root of 3, and we have 1, 2, 3, 4 faces the same way. So that's how you find the surface area, but you got to be able to do that with that isosceles triangle. Prove that the area is 4 times that. All right, this is the small one. Okay, this side here, all right, if this is x, this is 2x. All right, C, B, A is the big triangle. C, D, B, all right, this right here is x over 2. Actually, I'm sorry, square root of 3. No, that's the short side, right. Thirty side is x. This 30 side is here, so this is x over 2 square root of 3, and this becomes x over 2. So we end up with, to get from here to here, you multiply by 2 to get to x, you multiply by 2 to get to 2x, and that is a distance, that's a side of 4. So that's why it's 4 times bigger. Because half of a half of a half. All right, now. Okay, review. All right, the two I-beams are similar, and each linear dimension is larger by twice. Okay, so that makes whatever this is 2 times larger than this. Okay, if the cross-sectional area shaded here is 2 square feet, what is the cross-sectional area of the larger one? Okay, so if this is 2 square feet, all right, and what they're talking about is area. How many dimensions do you multiply together when you have area?
2.
Length times width, right? So I want 2 times 2. This will be 4 times bigger than this. So that means this shaded area is 8 square units. If it was volume, it would be 2 times 2 times 2, or it'd be 8 times the volume. Which is the next problem. Okay? So, if the smaller one is 6, then the volume of that will be 6 times 8, 48. If the smaller weighs 50 pounds, how much does the larger weigh? All right? The weight, I would think, is associated with...
Would it be volume?
With volume is what I would think. So therefore, well, I don't know. No, I think it would just be 2 times. Where is it up here? It's twice. So if it's twice as big, it should weigh twice as much. Time we got. Okay, suppose a polygon is similar to cube and the ratio is 3. All right, so Q is 3 and P is 1. All right, if P has an edge length of 2, how long is the corresponding edge length of Q? So P is 1 and Q is 3. So this is 1 times 2 and this is 3 times 2, or 6. If the perimeter of P is 12, then 1 times 12, this is 3 times 12 for the perimeter. If the area is 8, then that makes this 8, but this is 3 times 3. 9 times 8, 72. That is the work when you're talking about the difference between length and the difference between area. All right, and so because this was 3 times as big, if it's talking about area, you have 3 times 3 because you have 2 numbers multiplied together. If it's talking about volume, it's 3 times 2 times 3, which is 27. All right, and if you remember that, these are all pretty straightforward. Okay, how much time we got? 4 minutes, okay? All right, now, all right, let me see if I can get back to, where is it? Here it is, okay. All right, so, all right, what I'm going to do is I'm going to I'm going to allow you to finish the Chapter 7 test, because those trig problems are ones that you did not have, I don't think, a fair enough time. So you've got the trig, and then the Chapter 9 work you're going to have. I'm going to send you the Chapter 8 test. So I'd like you, as quickly as you can, to finish the Chapter 7 test, and then if you would, please upload that to me.
I should be able to get that to you.
That'd be fine. That'd be fine. I would say by tomorrow night. Okay, by Wednesday night, upload the finished Chapter 7 test. And then Chapter 8 test I'll get out to you today, and I would like you to bring that to class and submit that in class next week.
I will be here next week, so I just
I'm sad. Okay, all right, Abby, thank you for letting me know. I'll probably forget, but they'll remind me. Okay, all right. Okay, now, you're supposed to be working on Chapter 9. Is that something you're going to turn in? What? Midterm, yeah, okay, hang on, I'll talk about that in a second. All right. All right, you're supposed to be working on Chapter 9, which is this last work that we went through, so please be sure that you get that, because we're going to move right on through. And then I'm going to turn this off, and we're going to be done. Okay.